Okay, today I want to talk about section 10.3, the polar coordinates. This is outline. So I want to talk about the definition of the polar coordinate. The second one, I want to talk about how we can sketch a polar curve. The third one, first derivative and application. I can talk about these kind of things. So here, I can could you see this one? So what's it like some of the polar coordinate? I will explain some here. So first, so we have like 1 point. So we call this is a pole. You can draw horizontal ray, line ray, horizontal ray like this. So we call polar axis. So you can choose any point on the plane. I can choose point here. So this point is like P. So how can you express point P? By using polar coordinates. So you have to connect pole and point P. So like this. You can measure length between pole and P. The next to find angle. Make theta. So we can denote this is R theta. So what's that? So we call this one is polar coordinates. Polar coordinates. This is the idea. So one more. So you can use this is angle theta is this is like what's like a direction of angle theta. The direction of angle theta is like in the counterclockwise direction. We have theta is greater than 0. So we have another way for measure this angle like a clockwise direction. So we can use the like this. Like this one, this is another possibility for measure angle. So this is like, this is like angle alpha. This is -1. So we can use this is same to the R and alpha. So we have the infinity many possibility for measuring angle. So we have two directions like a counterclockwise direction, positive angle. Clockwise direction, we have a negative angle. The another method is the next one. So we have to use the one revolution here. So we have the same things in here. We have same kind of things. This one. Yeah, how can you measure this angle? One revolution. And add theta. What's that? This is the theta plus 2 pi. This is possible. The another one, we can measure like this. Here, one revolution is 2 pi. The two revolutions, another 2 pi, and add theta. Exactly. Theta plus 2 times 2 pi. So like this. And keep going. So another way is opposite direction. So here, so what's that? So we have this one. So like this. So we have clockwise direction. We have this one. -2 pi plus theta. This is theta minus 2 pi. So we have infinity many possibilities. What does it mean? We have general form. This is same to what? R theta plus 2m pi. N equals 1, only one revolution. N equals 2, 2 revolutions, and so on. So we have this kind of things. So what's it like N? N is any integer. Go like this, any integer. Okay, this is polar coordinate. The one more. How can you define negative length r? So we have here. This is a polar axis given the point P. Point P, so r and theta. So what's that? You can connect like this. This is length r, angle is theta. The next thing, you have to reflect this point P about the pole. So you have to reflect here. So this is same length, this one, and here you have to reflect. So like this. So we use this point P prime. You can use negative r theta. This is the definition of negative length. How can you find the negative length? You can plot point, the r and theta, next to you have to reflect about the pole. This point is negative length r and theta. So I can change this one to the positive length. How can you do that? So length is also r. You can change r. The one more. What is this angle? This angle is exactly pi. So we have theta plus pi. You can change the theta plus pi. The another way is we are going to the clockwise direction. You can use clockwise direction. Like this angle is negative pi. So this is exactly same to r theta minus pi. So either one is fine. So this is the definition of negative length r. Okay, this is like the whole concept of polar coordinates. Here, this is my explanation, the same, but like this one. So the next thing, we think about the example. How can you plot the point whose polar coordinates are given? First one, 1 and 5 pi over 4. How can you plot this one? So A. So the same. We have pole and polar axis is given. You can only write the angle 5 pi over 4. So what's 5 pi over 4? Here. This angle is here, the pi. So this angle is here, exactly 3 pi over 2. What's 4 pi over 2? Exactly the bisect this one. Here, this angle is exactly 5 pi over 4. So this length is like 1. So we have this point is exactly 1, 5 pi over 4. That's it. This is the idea. The second one is the same. Was it like 2, 3 pi? 2, 3 pi is exactly same to 2 pi plus 2 pi. Do you remember? So this is exactly same to 2 pi. This is the idea. 2, 3 pi is exactly same to 2 pi. So what's it like B? B is like this. So we have this one. What's it like angle? Pi. Angle is just pi here. This one. Length is 2. Suppose this length is 2. So this point is 2, 3 pi. This is the idea. And C. So same. You just only draw pole and polar axis, same. Was it like a negative 2 pi over 3? Exactly the clockwise direction. So here, So this one is the negative pi of 2, is like clockwise direction. This one is negative pi. What's that? We have here, like this. This angle is exactly negative 2 pi over 3. The next, you have to connect this point to the point P. What's like length? Length is 2. This length is 2. So this point is 2 negative 2 pi over 3. This is idea. What's like D? The negative 3 pi over 4 was like the main idea. The first, you can only use the like this. Pole and polar axis is given. The first, I want to plot positive 3 and 3 pi over 4. 3 pi over 4, you first. So here, this is pi over 2. This is pi. The 3 pi over 4 is here. The bisect this segment like this. We have it. So this angle is exactly 3 pi over 4. So length is 3. This is 3 pi over 4. The next, you have to reflect this point about the pole. Only reflect. So here, this length is same to this one, 3. So this is negative 3 pi over 4. This is the exact answer of these questions. Okay, this is like the one example. The next one here, the like this. I will explain this one. I'm gonna skip. So we have r theta is same to r theta plus 2m pi. The same to the negative r plus theta plus 2m plus 1 pi. Because remember, what's the relation between negative length and like a positive length? You can change this one to the negative length minus r. What's like way? You add pi. This is idea. The 2m pi plus pi is 2m minus 1 pi. You can change it like this. Oh, plus theta plus, sorry. Theta plus 2m pi plus pi. The another one is like this, same. The another expression is like change negative r, the theta plus 2m pi, just to subtract pi. This is like the same. You can combine this one. We have 2m minus 1 pi. So we have this relation. The next thing, so we think about the connection between polar and Cartesian coordinates. So what's that? So here, so we have the polar coordinate and Cartesian coordinate. First one, was it like a Cartesian coordinate? Do you know what is a Cartesian coordinate? Do you know what is a Cartesian coordinate? Oh, you're right. Like some the x and y. You're right. So we have sometimes we call rectangular coordinate. So we have it like this. So you can choose one point P here. You can find x component. You can find y component. So this is what? X, y. So we call Cartesian coordinates. So like this. Was it like a polar coordinate? So this the origin is a root of pole. The positive x-axis is polar axis. You can connect pole and P. So you can measure length R, angle theta. So this point, location of P is exactly same to polar coordinate R theta, the next one. right? So what does it mean? X is not equal to R, Y is not equal to theta, just same location. So I want to find the relation between polar and Cartesian coordinates. What's the relation? I want to use the trigonometric functions. So do you know what is cosine of theta? What's the cosine of theta? Do you know? Yep. This is right triangle, exactly adjacent over hypotenuse, x over r. You can use it. The sine theta is, what is sine theta? Yeah, y over here. Opposite over hypotenuse, y over r. So next is, I want to multiply the both sides by r. What is like x? X equals r times cosine theta. Here, y equals the r times sine theta. We have two things. So we have two relations. We have two more relations. What is tangent theta? Tangent theta is, do you know what is tangent theta? Yeah, y of x. Here, opposite over adjacent. So we have y over x. So one more. I want to use Pythagorean theorem. What's the Pythagorean theorem? So hypotenuse square r square equals x square plus y squared. This is Pythagorean theorem. So we have this kind of relations here, like this. This one. The next here. So we have it like this. So what's it like example? Convert the point 2 pi over 3 from polar to Cartesian coordinates. How can change it? That we can use the like this. This is like a polar coordinate. What does it mean? The 2 is r. Pi over 3 is theta. What's a Cartesian coordinate? We have x and y. So how can you find the x? By using r and cosine, r and theta, so we use this one. X equals r cosine theta. R cosine theta. So what's r? 2. 2 times cosine pi over 3. So do you know what's cosine pi over 3? Do you remember what's cosine pi over 3? Yeah, 1 over 2. It's good. 2 is crossed out, just 1. What's it like y? Y equals here. R sine theta. R sine theta is 2 times sine of pi over 3. This is 2 times sine pi over 3 is root 3 over 2. 2 is crossed out, only root 3. So what is Cartesian coordinates x and y? The x and y is here. X value is 1. Y value is root 3. We have it. This is whole idea for solving this problem. So like this. The next problem is opposite. Convert the point 1 minus 1 from Cartesian to polar coordinate. What does it mean? Here, this is x value. This is y value. You can change it to the polar coordinates r and theta. I can change it. In this case, you have to use the bottom one. R squared equals x squared plus y squared. Tangent theta equals y of x. You can use these two relations like this. So, was it like r squared? This one, you can plug 1 and minus 1 into x and y. As I said before, this is x. You plug, this is like x. This is like y. So we have, sorry, it's not this one. So 1 square plus minus 1 square equals 2. So what does it mean? So r square equals 2. What is r? What is r? So r squared equals to only square root of 2. So what do you think? The negative square root of 2 is possible or not? The plus minus possible, is right? So like this, yeah, the negative is possible. Why? Do you remember? So we have polar coordinates here. This is r and theta. Was it like a negative r and theta? You have to reflect this point about the pole. So this is negative r theta. This is possible. So my point is the r is positive or negative. Either one is fine. Either one is fine. But so which one is like easy to calculate the theta later? So positive one is better. So I can choose positive one root. The next is tangent function. Tangent theta is y of x. We use this one. So y is minus 1. X is 1. So exactly negative 1 over 1. We have minus 1. So what is tangent theta? The tangent theta is negative 1. What is angle theta? What's angle theta? The specifying tangent theta equals minus 1. What's theta? So do you have any idea? Pi over 4? No. So we have answer by using unit circle or reference angle. The first one. So what you like think about reference angle? What is reference angle? You can solve. Yeah, 3 pi over 4. The 3 pi over 4 is one answer. So do you have only one angle, 3 pi over 4? The only 3 pi over 4? What do you think? Do we have one more angle? Yes, 7 pi over 4. We have two angles. How can you find? So this is the idea. So you solve tangent theta prime. The theta prime is a reference angle. It is just a positive one. You solve. Or like a theta prime. Theta prime is like acute angle pi over 4. So here, so to remember this one, all students take calculus. What does it mean? All positive. Here, only sine positive, only tangent positive, only cosine positive. This is meaning here, tangent theta equals minus 1, negative number. What does it mean? Second quadrant and first quadrant. We have two quadrants. So we can use reference angle. Theta prime equals pi over 4 here. You have to reflect this segment about y-axis because the tangent function is negative, only reflect. Here, So what's like this angle? This angle is 3 pi over 4. Because this angle is pi over 4. Is right. So this angle is pi minus pi over 4. Pi minus pi over 4 is 3 pi over 4. We have one angle. One more. You have to reflect this segment about x-axis here. What's like this angle? This angle is negative pi over 4. So from here to here, what's that? This angle is like 7 pi over 4. Is right? It doesn't matter. Either is fine. 7 pi over 4, 1 negative pi over 4, either is fine. We have 7 pi over 4. We have two angles. The next thing. So which one is the final answer? Angle theta. 3 pi over 4 or 7 pi over 4? Which one? 3 pi over 4 or 7 pi over 4 or both? So what is your answer of angle theta? What do you think? What is your answer? Answer is only 7 pi over 4 because we are going back to original point. The original point is 1n minus 1. So what does it mean? The here. Is 1. This is minus 1 here. So this point. What's angle? Just this one. Exactly 7 pi over 4. Don't choose 3 pi over 4. What's the final answer? Final answer of polar coordinates are, so the length root 2, 7 pi over 4. This is your final answer. Or you can use negative pi over 4. It doesn't matter. Either one is fine. The square root of 2, negative pi over 4. We have either one is fine. This is answer of this question. So like this. The next one, polar curve. So the graph of polar equation, R equals F of theta, or more general form, the F R theta equal to 0, consists of all points P that have at least one polar representation R theta, whose coordinates satisfy the equation we call the polar curve. This is like a polar curve. So do you know what is Cartesian? This is a polar equation. What's a polar equation? R equals F of theta, F of R theta equal to 0. So what is polar? What is like a Cartesian equation? What is like a Cartesian equation? The Cartesian equation is the y equals f of x, or capital F of x, y equal to 0. So we call Cartesian equation. The next one. Oh, yeah, sorry, you're right. The students said that we can use 3 pi over 4 and negative square root of 2. You're right. Yes, it's possible. We are going back to this one. Sorry, I didn't see. Yeah, you're right. I want to change this one to the negative length. You're right. Negative length, this one. Yes. 7 pi over 4 minus pi. You're right. It's the same to negative root 2. Exactly. The 3 pi over 4. You're right. Yeah, thank you. Your comment. Yeah, thank you. This is like minus root 2, 3 pi over 4 is one more answer. You're right. Yes. Yeah, going back to this one again. Anyway, you need to know two kind of equations, polar equation and the Cartesian equation, both of them. Here, this example, the what curve is represented by the polar equation R equals 2. So what's that? What do you think? So what curve is represented by the polar equation R equals 2? So here, 2, 0. The 2, 0 is like 1 point. So what's like examining r equals to 2? This is the same to what's like angle theta? What's angle theta? Any angle. So what does it mean? Theta equal to 0. The theta equal to 0, length r equals to 2. The theta equals pi over 3. The r equals 2. The angle theta equals pi over 2. The length r equals 2. Length r doesn't change. This is like a key part. So we have circle, is right? Angle changes. This angle is this angle, theta 1, length 2, doesn't change. Angle theta 2, length 2, doesn't change. Angle changes, length doesn't change. Angle changes, length doesn't change. Angle changes, length doesn't change. Exactly, circle, the circle. So we can use like relation of polar Cartesian coordinates. So do you remember how can change this one to the Cartesian equation? So from here, you can scale both sides. So like this. This one. What is r squared? Remember, so we are going back to connection between Cartesian and polar coordinates. R squared is exactly same to x squared plus y squared equals 2 squared. Yes, exactly same to circle. That's right, the circle. So we have it. This one. Does it make sense? So next, sketch the polar curve theta equals pi over 4. What's it like a graph of a polar curve theta equals pi over 4? What's the graph? What is it like a shape of a graph? Do you remember the previous one, r equals to 2, we have circle. So we have a circle. What is theta equals pi over 4? You're right, line passing through the origin. What does it mean? The theta equals pi over 4. Angle doesn't change. Length changes, but angle doesn't change. So what does it mean? So here, so we have this one. What's like angle? Theta equals pi over 4. Here, theta equals pi over 4. Angle theta doesn't change. Theta is pi over 4. Right? So, what's that? The here, length equals 1, theta equals pi over 4. Length equals 2, theta equals pi over 4. Length is 3, pi over 4, pi over 4, pi over 4. Doesn't change. So we have this one. Is right? So that's it. This is the final. This is the final line, the final answer. It's final. So what do you think? So we need more here. You have to reflect this point about the pole. This one, what's that? This point is like -1, pi over 4. You have to reflect this point about the pole. This point is the -2, pi over 4. The -2, pi over 4. And so on. What does it mean? You have to expand on third quadrant. Exactly line. So one more. So I want to change this one to the Cartesian equation. How can change it? The theta equals pi over 4 is given. You can take tangent to both sides. What's like a tangent theta? The same. You are going back to connection between polar and Cartesian coordinates. Tangent theta is y over x. What's tangent pi over 4? Tangent pi over 4 is 1. You multiply the both sides by x. X is crossed out, so we have y equals x. Yes, this graph is exactly same to y equals x. So what's the theta equals pi over 4? Just a line, just a line. angle doesn't change. This is the key. So like this. The next one. The sketch the curve with the polar equation r equals 2 cosine theta. So what's like the best way? So we have some of the two methods possible. So I suggest that you can change this one to the Cartesian equation a little bit easier. I can show it to you. How can you solve this one? You can use same thing. You are going back to here. Do you remember this one? What is it like a cosine theta? The cosine theta is x over r. What is sine theta? Sine theta is y over r. What's it like r squares? X squared plus y squared. What's it like a tangent theta? Tangent theta is y over x. We can use like the relation between polar coordinates and Cartesian coordinates. So here, what's it like a cosine theta? Cosine theta is x over r. You plug into here, so we have r equals 2 times x over r. The next, you multiply the both sides by r. We have r squared equals 2x. The next, what's it like r squared? R squared is here. X squared plus y squared. We plug into here. X squared plus y squared equals 2x. So I want to sum the change. This is x squared. We can subtract 2x from both sides. So we have this one plus y squared equals 0. The next, we can change this one to the standard form of circle. What's the standard form of circle? Do you know this one? So we have, this is H. This is like a K. So we have circle. The radius is R. So what is the equation of the circle? X minus H squared plus Y minus K squared equal R squared. This is equation of circle. I'm gonna change this one. How can you do that? You have to use completing the square. What's a completing the square? The first, you can choose coefficient of x -2. Divide by 2. This step 1. Next, square. This result, -2 over 2 is -1. -1 squared is 1. The next, you add this number to the both sides, like this. Next, factor. First 3 terms, exactly x minus 1 square plus y square equals 1. 1 is same to 1 square. Exactly same to this form. So what's that? This is circle. Circle. What's like a center? Do you know center of a circle? Where's the center? Yeah, x component 1. This one is load of h. So 1. What is y component? Yeah, 0. Y square. Y minus 0 square. The 0 is k. The radius is here, 1. So what's like graph? The graph is like this. The passing through origin. This one. This is center is 1, 0. This is 2. we have a circle. It's good. This is the idea. The one more. The what is this graph? R equals 4 cosine theta. What's the graph? The same. You can use same procedure. Change what? This is 4. 4. 4. 4. How can you decide the number? Negative 4 divided by 2 is negative 2. The negative 2 scale is 4. So you add, this is 4. You add 4 from both sides. This is 2. This is 2 square. Center is 2, 0. Radius is 2. So what's R equal to 4 cosine theta? So graph is similar one. Only difference is center is 2, radius is 2. This is like 4. So could you find one good pattern for drawing the graph? R equals to 2 cosine theta, R equals to 4 cosine theta. What's like a root of 4? The root of 4 is exactly diameter. Diameter is 4, exactly x-intercept. So one more thing is, what is R equals 10 cosine theta? The R equals to 10 cosine theta is, this is graph. The same things. Graph is like this, circle. So this point is 10. The radius is half. So that's it. So like this. What is R equals negative 10 cosine theta? What's negative 10 cosine theta? You can use here only negative number. R equals negative, this is a negative, change positive, positive, positive. This is negative 2, the next one. What does it mean? So we have graph is here. Was it like negative 10? X-intercept. Only left-hand side. So like this point is negative 10. So this one is half minus 5. Does it make sense? So one more. R equals the 10 sine theta. What is R equals to 10 sine theta? R equals to 10 sine theta is like this one. You can change it. This is what? The R equals 10 times what's sine theta? Sine theta is y over r. You can use y over r. You can use complete the square. We have similar answers. So we have this graph. Graph is top one. Y intercept is 10. In this case, y intercept is 10. This is 5. What's R equals the negative 10 sine theta? The negative 10 sine theta is just bottom one. Y-intercept is negative 10. Here, this is negative 10. Center is minus 5. This is the whole idea. So for solving, the R equals constant times sine theta or cosine theta. Exactly circle passing through the origin. So what is it like some the law of coefficient of sine and cosine, x-intercept or y-intercept. But that's it. This is the whole idea for solving this kind of problem. Okay, so here it's good. So like this. This is another way for sketching the graph. So this is my method. It's better. So change it to the Cartesian equation. So like this. So one more problem. So one more problem is I run here. So I want to give another example. Another example is the next one. Convert. So Cartesian equation. To polar equation. How can change this one to polar equation? Same. We can use this one. x equals r cosine theta, y equals r sine theta, the r square equals x square plus y square. Another one. So tangent theta is y of x. You can use this relation. So here, what's it like x? X is r cosine theta. You plug into here. This is same to the r cosine theta minus 1 square plus what's like y here? R sine theta. R sine theta square equals 1. So next you have to expand. R cosine theta minus 1 square is the R square cosine the square theta minus 2R cosine theta plus 1 square is 1 plus R sine theta square is R square sine square theta equals 1. You can combine this one and this one. So what's that? R square cosine square theta plus sine square theta negative 2R cosine theta plus 1 equals 1, right? So what is cosine square plus sine square? Was it cosine square plus sine square? Yes, this is 1, so just 1. This is just 1. So we have R square minus 2R cosine theta plus 1 equals 1. You have to move negative 2R cosine theta to the other side. So you add 2R cosine theta to the both sides. You can subtract 1 from both sides. Cancelled, cancelled. So cancelled. So what's that? Only R square equals 2R cosine theta. So let me see. We have same R divided by R from both sides. Here, crossed out. What's the answer? So R equals 2 cosine theta. This is ideal for changing polar equation. So you need to know the both of them. Polar equation is given. You can change it to the Cartesian equation. Cartesian equation is given. You can change it to the polar equation. How can you change it? We always use this is four relations. This is ideal. Always use this four relations. This one. Okay, this is one more problem. The next So we are going to the next problem. So sketch the curve r equals 1 plus sine theta. So how can you sketch the graph? In this case, so if you change this one to the Cartesian equation, it's really difficult for sketching the graph. What's like the best way? The best way is like this. So first, you can draw r equals 1 plus sine theta, like Cartesian coordinate. The theta axis and the r axis graph is like this one is 1 plus sine theta. Next, you have to convert this one to the polar coordinates. So how can you use polar coordinates? So this is the idea. You can change it, polar coordinate. I can do that. I can show to you here. First one, angle 0. What's angle 0? This is theta equal to 0 here. The theta equals pi of 2 is this one. The theta equals pi. The theta equals 3 pi of 2. We have it. The theta equal to 0, length is 1. The theta equal to 0 is positive x-axis, length is 1. Length is 1, this point. Here, angle is increasing more. This angle is like theta 1. So what's theta 1? Angle is increasing a little bit, theta 1. Here, angle theta 1. Here, angle theta 1. What's length? Length is greater than 1. Here, this length, you have to draw, length is here. The a little bit greater than 1, this point. Here, you can choose here, theta 2 and this length. This is theta 2, so same. Theta 2 is this angle. This is angle theta 2. Length is greater than previous one, so a little bit greater than previous one, so like this. So keep going. Was it like 2? Angle 5, 2. The length is 2. Angle 5, 2 is positive y-axis. Length is 2. This is length 2. You can connect the end point. What happens? Graph is like this. So similar. Angle is increasing more. The length is decreasing a little bit. Is right. The angle is increasing more. The next one, the theta 3. Angle is theta 3. So what happens? Length is decreasing, the less than 2. So here, this one, the theta 4. Angle is theta 4. The next one, angle theta 4 is right. This angle is theta 4. Length is less than previous one. Length is less than previous one. So pi, angle pi is, length is exactly 1. The length is exactly 1 here. We can connect. So we can connect this one, so like this. Pi to 3, pi to 2, exactly third quadrant here. Angle is increasing more, like theta 5. The length is less than 1. Angle is theta 5 here. The theta 5. Length is less than 1. We have here. Angle is 352. What is 352? 0. You can connect. Graph is like this. You can connect. Similar. The 3 pi and 2 pi, the angle is increasing. What happens to length? Length is like increasing. Angle is increasing more here. This is length is this one. Increasing more, greater. Increasing more, length is greater. You can connect this point. We have this kind of things. That's it. So we have this graph. Make sense? This is the whole idea. You can only convert from the r and theta in the Cartesian coordinate to the polar coordinate. You just only connect end point. We have exact graph of r equals 1 plus sine theta. So here, like this, like this, like this, like this. So we have it. So what's that? So this is 1. Sorry, minus 1. This is 1. This is 2. We have it. So we have a name that we call cardioid. Like a cardioid. So what does it mean? So because it's shaped like a heart, we call cardioid. The cardioid, this is idea for sketching this kind of graphics. So one more. You can change it. This one to the like this. 2 plus 2 sine theta. So what happens? Same shape. Only difference is this is 2, this is 2, this is 4. So like this. So we have this kind of things. So what does it mean? The constant is exactly same to coefficient. We have a cardioid. What's it like r equals the 2 minus 2 sine theta? You can use same idea. The graph is like this. like opposite one. So this is 2, negative 2. This is 2. This is minus 4. So what is it like R equals the 2 plus 2 cosine theta? You can use same idea. You can draw the graph. So what happens? We have the like this. This is 4, 2, negative 2. What's R equals 2 minus 2 cosine theta? So we have same idea. Graph is like this. We have positive 2, negative 4. This is negative 2. We have this idea for sketching the graph. Does it make sense? We call cardioid. What's it like a cardioid? Very important thing. The coefficient constant is exactly same to coefficient. Constant is exactly same to coefficient. We have cardioid. This is idea. So next one, R equals cosine 2 theta. So we use same idea, the same idea. So what's that? So like this. So R equals cosine 2 theta. You can draw the graph in Cartesian coordinate, theta and the R axis. So you can convert this one to the polar coordinate. We have same idea. So here, what's that? You can draw the graph together. Oh. Here. This one. Here. So what's that? You can think about here. This is, we have angle theta equals 0. Angle theta equals pi over 2. Angle theta equals pi. Angle theta equals 2 pi, 3 pi over 2. This is also 2 pi. So we have like the 4 theta intercept, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Here. We have theta equals pi over 4. The theta equals 3 pi over 4. The theta equals 5 pi over 4. The theta equals 7 pi over 4. So what's like length? Length is always 0 at these lines. So let me see. How can I do that? Here. Angle 0, length is 1. Angle 0, length is 1. Here. The pi over 2. Sorry, pi over 4. So what happens? Angle is increasing from 0 to pi over 4. So what happens? Length is 1. Length is like decreasing till 0. So angle is increasing. Here, angle is increasing. Length is this one. Angle is increasing here and here. You can connect this endpoint, approach 0, so like this. What is pi over 2 and the pi over 2? It's like a negative length. We can use this idea. Do you know this one? So length is negative r theta. Same to what? Change it to the positive length theta plus pi. Like this one. You can add pi from the pi over 4 and pi over 2. So what happens? Pi over 4 plus pi is 3 pi over 4. No. Pi over 4 plus pi is 5 pi over 4. So pi over 2 plus pi is 3 pi over 2. So this part is going to this domain. The 5 pi over 4 and the 3 pi over 2 here. Going back to the next one. This is going to exactly 2. You can draw here. length, angle is increasing, length is increasing. So like this. So we have here. The 5 pi 4 and the 3 pi 2, right? Yep. So here. So what happens? Graph is like this, increasing and going to 1, like this. This is 1. This is 2. Was like 3? Same. So this part is going to here by using this idea. So angle is increasing, length is decreasing. Angle is increasing, length is decreasing. Going back to here. This is 3. So first one, 3 pi 4, angle is increasing, length is increasing. So we have here 3 pi pi, graph is like this. This is 4. Next one, pi and 5 pi 4. So angle is increasing, length is decreasing from 1 to 0. So here, like this. This is 5. Was like 6. We can use this one. Negative r theta is exactly same to r theta minus pi. You can subtract. 5 pi minus 4 minus pi is going to pi over 4. The 3 pi of 2, 3 pi over 2 minus pi is pi over 2. So this part is going to here. Is right, going to here. Pi over 4 and here, graph is like this. This is exactly 6. 7. This part is going to here. So we have decreasing. This is 7. Next, 7 pi 4 and 2 pi. Angle is increasing, length is increasing. From 0 to 1, so we have like this. This is 8. Okay, this is a whole idea for sketching the graph. So we have this one, so like this. So we have a name. So it is called a 4-leaved rose. So one more. So far, what is this is like a row of 2. This is double number of leaves. You can change it. This is 4. The how many leaves? We have 8 leaves. So we have the next one. You can use the same idea, cosine for theta. So what's like a graph? Graph is like this. We have 8 leaves. We have here 1, 2, 3, 4, 5, 6, 7, 8. The next one. So we have 8 leaves. What's like a coefficient? You can change the coefficient to 5. This is length. This is 5. This is minus 5. Exactly the length of leaf. The length of leaf is coefficient. Does it make sense? So like this. What is r equals cosine 3 theta? So we have an odd number. We don't have 6 leaves. In this case, only 3 leaves. So you can just sketch the graph in this case. Graph is like this. So we have only 1 leaf, second, and third one. Only 3 leaves. So like this. You can just sketch by yourself. This is always true. So when you have a double, the coefficient of theta is even number. The even number always twice. Number of leaves is twice. Was it like number is odd number? Exactly same too. Cosine 3 theta, we have 3 leaves. Cosine 5 theta, we have 5 leaves. What happens to sine function? Same. Only difference is a little bit tilt. So one example is r equals sine 2 theta. Was it like a graph? Graph is like this one. Only difference is This is sine 2 theta. This is only difference. This is only difference. R equals sine 2 theta. What is the number of leaves? The 2 times of 2. This is 4. We have n leaves. This is same. This is like the same. This is whole idea for sketching the graph of R equals cosine n theta, sine of n theta. So what's like shape? The n-leaved rows, n-leaved rows. We have this kind of result. So next one, R equals 1 plus 2 cosine theta. So how can the sketch the graph? No, I don't explain more. We have same method from the previous 2 examples. We have like this. So we have the graphs like this. So we call the Riemann. So shape is like this one, is right? The Riemann, we call Riemann. So summary of polar curve. The one more. How can you sketch the graph? The R equals 1 plus 2 cosine theta. When do you have like Riemann? The next one. You can compare constant and coefficient. The coefficient is greater than constant. We always have this kind of things like Riemann. What's it like a shape? Shape is like a snail. This one is like this one. So we have it always snail. So how can you sketch the graph? I will explain that later. This is like we have easy way. So for sketching the graph, this kind of things, explain that later. Here, summary of polar curve. So you need to know these kind of things. The R equals plus minus A. Was it like a graph? Circle with the center 0, 0, radius A. So what does it mean? So here, the one example is R equals 5. Was it like a graph? Graph is circle. Radius is 5. This one. What is R equals minus 5? So do you know what's the graph of R equals minus 5? Do you know? What is R equals minus 5? You're right, the same. Only difference is R equals minus 5. What does it mean? We can use this idea. This is R theta is given. How can this side the negative number? Only reflect about the pole. So negative R theta. So you can choose this point, reflect. Point, reflect. We have exactly same. We have same graph. Theta equals B is like a line passing through 0, 0, where the angle between the positive x-axis and the line is B. So one example is theta equals pi over 3. So what's it like a graph? Just a line, angle is pi over 3. That's it. This is a line. So like this. R equals plus minus A sine theta, R equals plus minus A cosine theta was like one circle with a diameter A passing through 0, 0, right? R equals A plus minus A sine theta, R equals A plus minus A sine theta. This is the key part. We have constant is exactly same to coefficient of sine and cosine. We have cardioid, shape is heart. The last one, R equals A plus, not last one, R equals A plus minus B sine theta, A plus minus B sine theta. We can compare A and B. Compare A and B here. The P is greater than A. What's that? We have Riemann. The shape is snail, like a snail. This is the last one. R equals plus minus A sine n theta. R equals plus minus A cosine times n theta. So what's that? Like rows. N-leaved rows. Number of leaves is n if n is odd number. The number of leaves is 2n if n is even number. So that's it. This is the whole idea. The one example is, I can show to you. Was like R equals 3 cosine 2 theta. The what's like the number of leaves? 2 is like even number. The number of leaves is 2n. Is right? 2n. So how can you sketch the graph? This idea is not difficult. Here, so you can plug theta equal to 0. What is r equals cosine 3 times cosine 2 theta? You plug 0 into theta. Cosine 2 times 0 is cosine of 0. Cosine of 0 is 1. 1 times 3 is 3. Angle 0, starting point is 3 here. So graph is that's it. This is the idea. Like this. Another one, r equals 3 sine theta. So was it like this one? This is 3, negative 3, and 3, the negative 3. Was it like root of the coefficient of cosine and sine? The length of leaf. The length of leaf is 3. R equal to 3 sine theta. So what's that? So similar. You plug theta equal to 0. Was it like r? You plug 0 into here, sine of 0. Sorry, sine 2 theta. The 3 times sine 2 theta. The sine of 0 is 0. Exactly. 3 times 0 is 0. Was it like a graph? The here, starting point is 0. Graph is like this. We have it. This is a whole idea for sketching the graph of loads. The next one. So how can you sketch the curve r equals minus 4 sine theta? So I want to use the previous one. This is what? R equals negative 4 sine theta. Here, we're going back to here. R equals negative 4 sine theta. We have circle. We know this kind of things. So like this and circle. How can you sketch the graph? This is the idea. You can make table is better. You can make table is better. How can you make a table? Table is like this. So we have the table. You can choose angle theta is, don't choose a lot. Only choose this is better. Only 5 angles. 0, pi over 2, pi, 3 pi over 2, and 2 pi. You can choose this point. You plug 0. The 0 into here. What is sine of 0? What is sine of 0? Yep, 0. 0 times minus 4 is length 0. The next one, r equals minus 4 sine theta pi over 2. Was it like sine pi over 2? Sine pi over 2 is 1. 1 times minus 4 is negative 4. You plug pi. What is sine pi? 0 again. The 0 times minus 4 is 0. You plug 3 pi over 2. What is sine 3 pi over 2? Yeah, minus 1. The negative 1 times minus 4 is positive 4. You can plug 2 pi. Sine 2 pi is like also 0. So we have 0. Next, you have to plug. Here, you can write theta equals 0. The theta equals pi over 2. Theta equals pi. Theta equals 3 pi over 2. Theta equals 2 pi. So we have it. Next, angle 0 has length 0. This point. The pi over 2 has minus 4. What does it mean? Negative 4 pi over 2. The negative 4 pi over 2 is exactly same to 4 pi over 2 plus pi. Is right? So we have 4, 3 pi over 2. What's that? The 3 pi over 2 length is 4. 1, 2, 3, 4. We have it. This point. Pi 0. Length 0. Again, origin. 3 pi over 2 is 4. We have same. The 2, 5, 0 is like 0. What's that? You can connect these 2 points by using circle. That's it. This is the idea for sketching the graph. Only use table. The next one, r equals to 2 minus 2 cosine theta. We are going back to previous one. So what's that? We have constant is same to coefficient. We have cardioid. This is the idea. We have cardioid. You can use table. This one is cardioid. You can use a table. So next, so how can you sketch the graph? The same. So you have to use table. What's it like theta? Theta is same. Angle 0. Pi over 2, pi. 3 pi over 2, and 2 pi. You can choose this point. You plug 0 into cosine. What's the cosine of 0? Cosine of 0 is 1. The negative 2 times 1 is minus 2. 2 minus 2 is 0. Is it right? You plug pi over 2. Cosine pi over 2 is 0. So 2 minus 2 times 0 is 2. You plug pi. Cosine of pi is minus 1. Minus 1 times negative 2 is positive 2. 2 plus 2 is 4. You plug 3 pi over 2. Cosine 3 pi over 2 is, what's that? 0. 2 minus 2 times 0 is only 2. You plug 2 pi. Cosine 2 pi equals 1. We have 2 minus 2 is 0. The next thing, you have to plug these points. The same, similar. Here, it's the same. Theta equals 0. Theta equals pi over 2. The theta equals pi. The theta equals 3 pi over 2. Theta equals 2 pi. It's the same. The 0, 0. Angle 0, length is 0. Pi over 2, length 2. The angle pi over 2, length 2. 1, 2. Here. Pi 4. Angle pi, length 4. 1, 2, 3, 4. Three pi over 2, length 2. Angle 3 pi over 2, length 2. Here, 2 pi 0 again. You can connect this one by using heart. How can you make heart? Here, like this. So we have it. This is the whole idea for sketching the graph. This one. The sketch the curve r equal to 2 plus 5 sine theta. What's that? This is 5. The coefficient of sine is greater than constant. We have Riemann. The next one, Riemann. The shape is like snail. The snail. So same. You choose 0, pi over 2, pi, 3 pi over 2, and 2 pi. So you can plug. You plug 0, sine of 0 is 0, only 2. You plug pi over 2, 2 plus 5 sine theta is 2 plus 5, 7. You plug pi, sine pi is 0, 2 plus 0 is 2. 3 pi over 2, 2 plus 5 times minus 1, negative 3. You plug 2 pi, sine of 2 pi equal to 0, only 2. We have these numbers. So what's that? You can draw. Same. Theta equal to 0. Theta equals pi over 2. theta equals pi, the theta equals 3 pi over 2, the same. Theta equals 2 pi. Here, 0, 2. Angle 0, length is 2. We have it. Pi over 2, length is 7. So 1, 2, 3, 4, 5, 6, 7. This one. The pi length is 2. Length is 1, 2. This one. The 3 pi over 2 is minus 3. So what's that? You can use this one. Negative 3. 3 pi over 2. I want to use this one. Change it to the positive length. The 3 pi over 2 minus pi. What's that? This is 3 pi over 2. What's that? 3 pi over 2. Here, right? So, like this. And 2 pi, 2 again. You can connect this point, this point, this point, this point by using snake. How can you do that? So like a small length, this one, we have one loop. Small loop is like this one. The bigger one has like shape is this one like a heart. So like this. So that's it. This is the whole idea for sketching the graph Riemann students. Like this. Right? We need one more things here. Symmetry. So in this graph, the R theta is the symmetric about Rn minus theta. What's that? Here. If a polar equation is unchanged when theta is replaced by negative theta, the curve is symmetric about the polar axis, right? The polar axis is this one. So what's that? So this one is, oh, sorry. So this one is polar axis. The polar axis. Here, the polar equation is unchanged when R is replaced by negative R, or when theta is replaced by theta plus pi, is right here. This angle is what? Add pi. So theta is replaced by theta plus pi. The curve is symmetric about the pole. Here, a polar equation is unchanged when theta is replaced by pi minus theta. The curve is symmetric about the vertical line. Theta equals pi over 2. What's theta equals pi over 2? This line. This line is theta equals pi over 2. So like this. We have 3 kinds of symmetries. The next thing. The selection of the last part, tangent to polar curve. Tangent to polar curve. X equals R cosine theta, Y equals R sine theta. So we know this relation. So given a polar curve, R equals F of theta. What's like X? We can use this one. X equals R cosine theta. You plug F of theta into here. We have F theta cosine theta. So Y equals R sine theta, same. You plug F of theta into R, F of theta times sine theta. So what does it mean? This is parametric equation. We have the X is equation of theta, Y is equation of theta. We call parametric equations. That's right? Parametric equations. How can you find the slope tangent line of parametric equations? We can use the section 10.2. X equals h of t, y equals g of t. Was it ty of dx? Ty of dx is ty of dt over dx of dt. Exactly g prime of t over h prime of t. So what does it mean? In this case is only replace. Was it like x? h of theta, g of theta. Exactly dy of d theta, dt of d theta, g prime of theta, h prime of theta. So we have it. This is exact derivative of parametric equations. So was it like a dy of dt of a polar curve r equals f of theta? We can use this rule, dy of d theta over dx of d theta. Exactly f of theta sine of theta prime over f of theta times cosine of theta prime, because was it like y? This y is here. You can plug into this one. Was it like x? This one. Oh, sorry. So f of theta sine theta is y. Plug into here. So x is f of theta cosine theta. You plug into here. So we have this rule. How can you find f of theta sine theta prime over f of theta times cosine of theta prime? So we use product rule. F prime of theta times sine theta plus f of theta times sine theta prime. The sine theta prime is cosine of theta. The bottom one, f of theta times cosine of theta prime, the same product rule. F prime of theta times cosine of theta minus f of theta times cosine of theta prime. Cosine of theta prime is negative sine theta. We have it. This is the whole idea. The next tip. So we think about this problem. For the cardioid, r equals 1 plus sine theta. Find the slope of the tangent line when theta equals pi over 3. Find the point on the cardioid where the tangent line is horizontal or vertical. So we use this kind of things. So first one, you can use relation. X is always r times cosine theta. So you plug r. What's r? 1 plus sine theta into r. We have it. 1 plus sine theta cosine theta is x. Was it like y? R times sine theta. Same. You plug 1 plus sine theta into r. We have 1 plus sine theta times sine theta. The next tip, find slope of tangent line. The slope of tangent line is ty of dx. What's it like ty of dx? You can use it. Here, what's that? Ty over d theta over dx over d theta. What's it like ty of d theta? The y is here, this one prime. 1 plus sine theta times sine theta prime over dx of d theta is x prime. This is x. So we have 1 plus sine theta times cosine theta prime. Like this. So we have it. This one. The next product rule. So 1 plus sine theta prime times sine theta plus 1 plus sine theta times sine theta prime. We can use product rule. Bottom one, similar. We can use product rule. So what's that? What is 1 plus sine theta prime? What's 1 plus sine theta prime? What's that? Could you write your answer on the chatting board? What's 1 plus sine theta prime? Yeah, thanks. This is cosine theta. You're right. So this is cosine theta. The sine theta prime is cosine theta. What's cosine theta prime? What's cosine theta prime? Negative, you're right, yes. Negative sine theta, like this. So we have it. The next, combine. Cosine theta is common factor. You factor out cosine theta. What's that? We have cosine theta. Sine theta plus 1 plus sine theta over. Here, distribute negative sine theta. We have cosine theta minus sine theta minus sine square of theta. What's that? Sine theta plus 1 plus sine theta is exactly same to 1 plus 2 sine theta. Right? So we have like this. The next one, I wanna factor bottom one. How can you factor? We have a cosine function and sine function is given. I can change cosine square of theta to the sine function. What's that? 1 minus sine square of theta. So what's like a bottom one? This is 1 minus sine square of theta minus sine theta minus sine square of theta. So what's that? This is 1 minus sine theta minus negative sine theta square. Negative sine square theta is negative 2 sine square of theta. The next, I wanna factor. This is 1 plus sine theta 1 minus 2 sine theta. You factor like this. So we have it. So like this. The next, you have to plug pi over 3 into here, theta. Here, you can plug into here to find this one. So what is cosine pi over 3? What's cosine pi over 3? Yep, 1 over 2. What's sine pi over 3? The square root of 3 over 2, you're right. The sine pi over 3 is the square root of 3 over 2. Sine pi over 3 is the square root of 3 over 2. So we have like this. The next is the simplify. 2 is crossed out, right? So what's that? This is same to 1 over 2. 1 plus root 3. This one was like a bottom one. 2 is crossed out. Exactly. The 1 plus root 3 over 2. 1 minus root 3. You have to use FOIL rule. 1 times 1 is 1. 1 times minus root 3 is negative root 3. The plus root 3 of 2 times 1 is positive root 3 of 2. The root 3 of 2 times minus root 3 is negative 3 of 2. Here, 1 minus 3 of 2 is negative 1, right? Negative 1/2. Minus root 3 plus root 3 of 2 is negative root 3 of 2. I know factor minus 1, minus 1/2. Minus 1/2, 1 plus root 3. So we have it. So what's like bottom one? Minus 1/2, 1 plus root 3. So what happens? Cross out everything. So we have 1 over minus 1. Answer is negative 1. So that's it. This is whole idea. for solving first problem. Like this. Next, find the points on the cardioid where the tangent line is horizontal or vertical. So we can use previous result, dy of dx. The dy of dx is cosine theta 1 plus 2 sine theta 1 plus sine theta 1 minus 2 sine theta. So was it like a horizontal line? So was it like horizontal? The key part is, not y equal to 0. So dy of dx is right. The slope equal to 0. It's like a key. Was it like a vertical? Dy of dx is what? Undefined. Yeah, undefined. Undefined. The two kind of things. Was it like this case? Only dy of dx equal to 0 exactly. What's that? Numerator equal to 0 is right. Only cosine theta 1 plus 2 sine theta equal to 0. Was undefined. Which one equal to 0? Was undefined. So which one equal to 0? Only bottom one equal to 0. Undefined is right. Only bottom one. Here dx over d theta equal to 0, but dy over d theta numerator is non-zero. This is case 1. Do you know one more case? The second case is here. Bottom one equal to 0 and top one equal to 0. This is also undefined because 0 over 0. In this case, you calculate limit dy over dx. You calculate this limit. So the theta value approaches like a given point like A. You can choose a point A. So satisfies this one. Like theta equals A, the theta equals A, we have all 0. So answer is, we think about only one side limit is possible, only one side limit. The left hand side or right hand side, it doesn't matter. Or the theta approaches right hand side or left hand side, we have infinity or the minus infinity, we have vertical tangent line. We have two cases. The two cases in the vertical asymptote. This is key. So what's it like a key? The top one equal to 0, we have a horizontal asymptote. The bottom one equal to 0, we have the vertical tangent line, but we have two cases, is right? So top one is non-zero. Exactly, we have some vertical at the vertical tangent line. The top one equal to 0, bottom one equal to 0. You have to check limit of slope dy over dx. The limit of dy over dx is going to positive infinity or negative infinity. So we have a vertical asymptote. We use these kind of things. The first one, the horizontal tangent line dy over d theta equal to 0. Which one equal to 0? Exactly, top one equal to 0. Top one equal to 0. So like this. Only first one, cosine theta equal to 0, 1 plus 2 sine theta equal to 0. So we have like so. Cosine theta equal to 0. Here, subtract 1 divided by 2. We have sine theta equals minus 1/2. What is angle theta? So first one, cosine theta equal to 0. What's angle theta? So you don't need all angles. We need only angle theta is just 0 and 2 pi. Only 0 and 2 pi. You don't need more. So cosine theta equal to 0. What is angle theta? Yep. You can draw the cosine graph. Cosine graph is like this. Here, this is cosine of theta. Angle is pi of 2. This angle is 3 pi of 2. We have these two angles. So we have pi of 2 and 3 pi of 2. Two angles. The sine theta equals minus 1/2. What is angle? Do you know sine theta equals minus 1/2? You can use unit circle method or like reference angle, you have it. So I want to use a reference angle. Sine theta prime equals 1/2. What is theta prime? Pi over 6. So you can draw here. All students take calculus. So sine function is negative angle. Which one? The third quadrant and the first quadrant. You can use reference angle pi over 6. Here, like pi over 6. You can move this one to the third quadrant. Only reflect the origin. So we have it. The reflect about x-axis. So this angle is 7 pi over 6. The other one, this angle is 11 pi over 6. We have two angles, 7 pi over 6 and 11 pi over 6. We have two more angles like this. dx of d theta equal to 0. Only bottom one equal to 0. So exactly the bottom one. 1 plus sine theta, 1 minus 2 sine theta equal to 0. So 1 plus sine theta equal to 0 or 1 minus 2 sine theta equal to 0. So you subtract 1 from both sides. Sine theta equals 1. You add 2 sine theta to the both sides and divide by 2. The sine theta equals 1/2. We have two equations. Find angle theta. Sine theta equals minus 1. What is angle theta? What's angle theta? Yes, 3 pi over 2. So graph of a sine function. What's a sine function? This is a sine function. So here, 3 pi over 2. We have minus 1. Yeah, angle is 3 pi over 2. Sine theta equals 1/2. Do you remember what's angle? Pi over 6 from the previous one. One more. This is angle pi over 6. You can use all students take calculus. What does it mean? Sine function is positive in second quadrant. You have to reflect about y-axis. This angle is pi over 6. Was it like original angle, this one? This original one is pi minus pi over 6 is 5 pi over 6. We have one more angle, 5 pi over 6. So we have a horizontal line theta equals pi over 2, 7 pi over 6, 11 pi over 6. The y only top one equal to 0. Remember, was it like a horizontal tangent line? Only top one. Top one equal to 0, but bottom one is not equal to 0. Top one equal to 0 is pi over 2. So we don't have it. The 7 pi over 2, 11 pi over 6. But what's 3 pi over 2? Here, both of them. Exactly top one 0 and the bottom one 0. So far, we don't know. So one more. Vertical tangent line. What's case 1? The case 1 is dx over d theta. dx over d theta. Bottom one equal to 0, but top one is non-zero. It's case 1. Case 1, exactly here. Pi over 6 and 5 pi over 6. So exactly bottom one equal to 0, but top one is non-zero. We have two angles. What happens? 3 pi over 2. What's 3 pi over 2? What's 3 pi over 2? Top one equal to 0, bottom one equal to 0. Is right? The top one equal to 0, bottom one equal to 0. In this case, you can take limit. This is the idea. Take limit. The limit dy over dx, theta approaches 3 pi over 2. You can use this idea. So like this. So you can split the zero part and the non-zero part. So what's like a non-zero part? So you can plug 3 pi over 2 into here. What's cosine 3 pi over 2? cosine 352 is, what's cosine 352? Exactly 0. You plug 352 into here, minus 1. 1 minus 1 is, this is going to 0. This whole thing is going to 0. You plug 352 into here, the non-zero here, non-zero. You have to split two things, the non-zero part and the zero part. You plug 352 into sine. What's it like a sine function? I just said it before. Here, this one, 352. We have minus 1. So this is 1 minus 2. Bottom one is 1 minus 2 times minus 1. Exactly the negative 1 over 3. So this part is negative 1 over 3. So we have it. So like this. Was it like this one? Exactly 0 over 0 form. You have to use L'Hopital's rule. Can use L'Hopital's rule. The cosine theta prime is negative sine. 1 plus sine prime is cosine. So we have it. The next, what's that? You plug 352 into top one. So what happens? Negative sine 352 over cosine 352. What's that? Sine 352 is minus 1. The minus 1 times minus 1 is positive 1. Cosine 352 is 0. We have 1 over 0 form. We have two possible answers, infinity or negative infinity. How can you decide? You can use one-side limit. Was it like a bottom on cosine function? Cosine function is like this. This is cosine function. This angle is 3 pi over 2. Was it like top on positive? Very clear. Was bottom on? Theta approaches 3 pi over 2 from the left. Theta value approaches to 3 pi over 2 from the left. What happens to cosine function? Cosine function is under the x-axis, like negative number. So this is what? Negative. So what does it mean? Minus infinity. This whole thing approaches to negative infinity. What's that? The minus 1/3 times minus infinity is positive infinity. We have like this. What does it mean? We have vertical tangent line at theta equals 3 pi. This is true. So I can summarize. The slope of the tangent line at pi over 3 is minus 1. There are horizontal tangent line at theta equals pi over 2, 7 pi over 6, 11 pi over 6. There are vertical tangent line at theta equals 3 pi over 2, pi over 6, 5 pi over 6. I can check. This is true or false. You can draw graph. The original graph is r equals 1 plus cosine theta. Does it make sense? Here, angle is this one. What's the angle? And this point, angle is pi over 3. So this is tangent line, slope is minus 1. This is exact meaning. We have 3 horizontal tangent line. This one, and this one. Yes, pi over 2, 7 pi over 6, 11 pi over 6. We have the 2 vertical tangent line here and here. So we have 5 pi over 6 and pi over 6. One more. This one here is right. Graph is what happens this graph? The like theta value approaches 0 here. What happens? Tangent line is approach to the positive infinity, right? Like increasing more, approach to the infinity. We have one more thing is here, angle is 3 pi over 2. So this is whole idea for solving problems in section 10.3. Okay, so this is all for today lecture. So do you have any question in the section the 10.3? So if you have any question, you can write your question on the chatting board. So if you don't have any question, you can leave the live session. So thank you for attending the live session. So thank you very much. You're welcome.